good to see you. It's been about a year and a half, almost 2 years since we talked last, I believe, I think.
Yeah, absolutely. Yeah, but it's a lot's happened since. So
Quite a bit has
yeah, on
happened,
both sides.
and a lot's remained the same. Uh,
Yeah. Yes.
I wanted to talk to you today, hoping that we could dispel some of the more common misconceptions, myths, uh, and kind of reveal some of the realities about 3D printed construction so that people can listen and get an idea of you've been watching this industry for how many years?
Uh Almost 2015, so 7, 8 years now since we
Yeah.
started.
So I guess maybe we just go back and forth. Would you like to start off? What do you think the biggest myth is in 3D printed construction?
The biggest one still remains, unfortunately, is price. So people assume that when you 3D print houses, you're still going to get them for cheap, like $5,000, $10,000, which is very unrealistic. But people still, I still get calls today where it's like, oh yeah, we heard that we can 3D print houses for cheap, and we just want to learn more about this amazing technology. And I try to explain the facts as to when it comes to that. So one of the biggest ones that we still face today is the price.
Mm-hmm. Yeah, it's funny in a 3D printed construction job site. I used to do construction auditing, comparing subcontractor receipts to their payroll taxes to make sure everybody's reporting the right numbers. And without a doubt, on every construction site, people try to make it look more expensive than it actually was so they can charge more money. However, in a 3D printed construction site, they do the opposite. So instead of trying to make things look more expensive, they mask costs and they don't include the shipping, the printer assembly. And I've noticed often the skills needed to operate these systems are very specialized. So
Mhm.
it's hard to put a price on the team. Some of them are pretty irreplaceable.
Yeah, they do. But also, like when especially when you're doing like one-off projects, like a single house here or a single house there or a couple of houses here, there's a lot of training associated with the project itself. So again, like you mentioned, there's logistics, there's training, there's manpower that you have to bring in for one time. So there's a lot of costs associated with the initial print that you do that is not carried on other prints because later on the either the company or the general contractor will actually buy or lease this machine. So, but they'll be running their own personnel to actually do all the printing. So there's a lot of costs associated with the initial print that people don't realize. But again, also there's ongoing running costs that you might benefit out of it. So people are focusing just only on the construction, but not realizing that your 3D printed house is not going to blow away in a couple of years if there's a tornado or a hurricane. Is not going to burn down if there's a fire. But also your running costs in terms of your ambient temperature, how much you're going to spend on heating and cooling, all that can be offset in the future. So you're saving on the long run, even though on the short run, you might think that, okay, you're spending more money.
Yeah, cost is definitely the big one. And I guess I'll go next. The big myth is that a house can be printed in 24 hours
Yes.
or just time in general. I see these claims often, and they say print time or something specific like time active, and they're not lying, but the language they're using makes it sound like the project was completed in less than 12 weeks, 16
Mm-hmm.
weeks.
Mm-hmm.
I haven't seen any of these projects come in much faster than a traditional construction project because of all the associated subcontractors and having to try things for the first time.
Mm-hmm. Absolutely. I mean, like everybody's doing things differently. So some people are printing and leaving the holes for the MEP as part of the print. Some people are actually printing full walls and then cutting things out. So everybody's still on a error trial process when they're trying to see what works and what works best for that solution. And some people are taking it one step further and say, okay, I'll do the formwork for the slab or I'll do something else. So there's everybody's doing something different, so there's not one way of doing things. And as because people are learning and trying to adapt, this is also something that is different from one project to the other. Also, everybody's using different materials. Some people are trying to use mortars, other people are trying to move away from mortars and more conventional aggregate and regular concrete. So you cannot do a one-to-one comparison, especially when you're comparing stick build or traditional construction with your 3D printing construction.
Yeah. When we have more data, hopefully there'll be more comparisons to make. I guess before we go to a third myth, I want to circle back to the price thing. From what I've seen, there haven't been many people totally transparent about their prices, but those who have, it seems to be around 40% more expensive than a traditional project. And that 40% number, it's very qualitative, but it's consistent as well.
Yes, only because you have, well, there's, again, if you're doing everything on one single project, if you're doing, for example, an 80 square meter house and you're bringing a printer and material and expertise and training and everything's riding on that single house and that single project, yes, it's going to cost more. Definitely, it's going to cost more. What people don't realize is that if I'm doing that for 10, 15, or 20, or even 100 houses, I'm bringing in the equipment once, I'm doing the training once, and I'm doing the logistics once, but the price is offset on that project. So then it becomes more realistic and more conventional. But
interestingly, the 40% above expense, those didn't include training costs or any of the costs that you mentioned. So, I mean, that gets into the realm of speculation, right? Because nobody's completed a project of that size yet.
No, but like when we were doing the house in Saudi Arabia, there was a hefty logistics cost, and not just logistics. I mean, you're talking about customs clearance and hiring the agents to actually do that. There's a lot of stuff that goes beyond just the construction
but it's
side.
still speculative, right?
Exactly.
It's speculative that because I haven't seen any of these companies achieve scale yet. Nobody's printed more than maybe 6 tiny units together, but in terms of an actual single family residential home, yeah, I mean, we'll have to wait and see for one of these 100 home projects to come to fruition.
Yep.
Do you have a third myth ready?
Yeah, people seem to think that 3D printing is this phenomenon that nobody can relate to when it's not. The approach towards 3D printing is just like you would do any other piece of equipment on your construction site. There are two things. First, 3D printing has to address a pain point. You're not going to get a 3D printer just for the sake of getting a 3D printer, just because it's the latest and greatest thing out there and we want to be part of the hype. You have to equate 3D printing just like you would do any other piece of equipment. So like if you're buying a crane or a bulldozer or an excavator, you're buying it because there's a specific reason why you're buying that, or there's a specific job you want to do when you're buying it. You wouldn't invest so much, like $1.5 million in a piece of equipment if you're just going to have it sit and then figure out, okay, how am I going to use it? And the same depreciation, the same investment, and the same thoughts and the same reservations that you would have when you're buying this big piece of equipment has to be carried out when you're buying a 3D printer.
I think that's a dangerous analogy because there's no financing options for the concrete printer. There's no compelling financing options yet. And also those dozers and the other construction equipment, there's thousands of trained operators. And there are, it's not equipment that companies usually buy. Like the companies purchasing concrete printers, none of them own dozers, none of them own cranes, none of them own any of those things. They rent it all the time.
Not necessarily, because like as a general contractor company, we owned our equipment. So we owned our machinery, and it was easier for us to actually just take it from one side to the other than actually keep on leasing it and finding a different subcontractor in a different location. So,
but what about the number of operators available?
The
you
number,
think it's simple?
Sorry?
You think that the printing is more simple, or it's as simple as traditional construction equipment?
If the training is happening with no, I mean, like it depends on what you're doing. If you're doing the printing itself and where you're just monitoring the software, and then, yeah, that's something that could be done by an engineer or a technician. But the complexity comes into the material science, and that's not something you can just like find anywhere off the shelf. I mean, there has to be a dedicated person who actually does the material and to augment the material and troubleshoot the material as it happens.
That's a real challenge. Every time I've seen a new project site, they always struggle with the material on a new location. It's never just quick and easy.
Yeah, that's number 4. Where the myth comes into play. Just to segue out of that, I mean, when you're dealing with material, just because the material and equipment works, we're not talking international. Just let's take US. Just because it works on the West Coast doesn't mean it's going to work on the East Coast and magic is going to happen and or you're go off and printing from day one.
And just because it works at 6 a.m. doesn't mean it'll work at 9 a.m.
Exactly. So you have to take your consideration into testing the material, making sure that the material that you have, even though it's a verified mix and formula, that you actually do your due diligence in testing it and making sure that you're getting the consistency that you want and not just jump to conclusions that just because it works in one location, it's going to automatically work in the other location.
Yeah, the myth I was going to do next was that you can press a button and print a house. It's never that simple. And you kind of hit the nail on the head at the mixer pump system. Maybe it's not the printer. Maybe on the printer, you can click a button and if everything goes well, it's fine. But you need at least one person loading the mixer pump system and probably a couple people observing, maybe one observing the printer, making sure the hose doesn't hit, and one observing the team for safety. Really just 3 people, bare minimum, absolute bare minimum. And that's usually 4 people, 5 people. You get someone like me filming and 6 people on site. So yeah, it's not just click, print, go. And if there was, you'd get a lot of concrete spaghetti prints, I think.
Yeah, I mean, again, there's a lot of trial and error that goes out there, but you have to be realistic as to your output and your expectations, and it's not just a magical. Again, it's not a magical piece of equipment or that's just going to be installed and boom, it's going to work and everything's going to come out just perfect. It doesn't work that way. You have humidity, you have temperature, you have the water, the material temperature, the water temperature. If it rains, if it's cold, if it's hot, if there's wind, you have so many factors that play into this. So that just because it works in one location with the same formula, with the same equipment, it doesn't mean that it's going to be automatically a go on the next site.
Yeah. Do you have another myth?
That it takes away jobs, which it doesn't.
I agree.
What's happening now realistically is that the labor force in construction is actually reducing. There's a lot of tacit knowledge that is out there in the existing labor force that is not being transferred to the new generation. And when I mean about tacit knowledge, it's the knowledge not necessarily that you find in books or documents or colleges or universities. It's the work experience that every construction worker has had or gained or developed over the years as working in construction. This experience is not documented anywhere. And this experience is being lost in the construction sector as people retire and get out of the construction sector to move away. So the younger generation doesn't have that value that was generated over the past 50, 100 plus years when it comes to the construction sector. And we have to consistently learn over and over again through our mistakes, through trial and error, trying to get there. The existing labor force has a big chance of actually teaching the younger generation and the new generation of how to actually build without having to start and reinvent the wheel from the beginning. Even though we're using robotics, even though we're using new materials, even though we're using different approaches, 3D printing is just another tool in construction. And I try to emphasize that as much as possible. So the dynamics of how you construct or how you build is still there. And that knowledge that the existing labor force has is invaluable when it comes to moving forward and making this construction sector or this tool more productive and more efficient in the way it moves forward.
Nice. Yeah, I agree completely. Even historically, when technology has replaced jobs, it's freed up those people to do more mindful work generally. And it's like the situations you cited, it's not even an occasion where people are losing their jobs. I have never heard of someone getting replaced by a concrete printer, but maybe if some of the other myths we talked about became true, it would start to have a bigger impact in that way. Like if it was more cost effective, clearly.
Yeah, but again, that experience is invaluable. When you're looking at the experience and the knowledge that you get over the years in your construction, just little things like, for example, using a wrench, a different type wrench or a different type screw, or where to put formwork and where to put tension or where to focus on or where not to focus on, just simple things that you gain by trial and error and just having that would just make things much easier. But also, just because you're using computers and using robotics and different materials, there's still that knowledge and I say, okay, well, I think even though you're using this, but there might be a better way of doing it. And you have to keep in mind, for example, not just temperature and wind and heat, but maybe some other factor like your surrounding temperature or the vibration around your, or how many workers are there at site or something like that. Something that people just don't realize that has an effect on your material and your print and your construction site.
Nice. I would say the next one is that 3D printed construction eliminates construction waste. A lot of companies look at construction waste and they just see the averages. And most people on a construction site, they aren't considerate about that because someone else is paying for the materials. So they over order, they're reckless with their cuts. They might cut something in half and then throw away the 4-foot piece of wood just to cut something else 4 feet somewhere else. Replace broken windows, all kinds of stuff. A considerate job site can reduce their waste tremendously from the average without any technology, just by being considerate. So the 3D printed construction companies, they're trying to be more considerate, but oftentimes they're not. So they can make mistakes. They might do a substantial portion of a print that they have to destroy and redo. Most of them, almost none of them are actually recycling their material. It takes so much effort to crush it up and reuse it. Even though you could do that, it's not being done. So yeah, I don't think that 3D printed construction is really reducing waste much on the job site.
It might later on when you're using like sort of like the as much material as you need when you're printing.
Yeah.
But again, it's something that it's debatable. It's hard to figure out now if it is actually zero waste or not. But again,
it's definitely not zero because they have to get the mix right. So they have to run the powder slowly at first. There's always waste. It's a matter of how much waste. And if you're good, it's very little. If you're not great, it could be a tremendous amount of waste. Just like in real normal construction sites traditionally. Yeah, I mean, we're really waiting on data so that we can do more scientific analysis rather than qualitative analysis, right?
Yeah, and also waste comes at a cost. I mean, like you have to pay to get rid of the waste on your construction site. I mean, as a general contractor company, when we worked, we had our projects, but we also had to segregate our waste. Like, where's the wood, where's the concrete, where's the rebar, and then send it out to a recycling agency to actually do the recycling or actually dispose of the material. So there's a big cost. If we can reduce that, and 3D printing promises in the future to do that, then that will be a cost saving on your project as well.
You worked for the GC that built which building in Dubai?
Several buildings. We built the company I used to work for. We built a midfield terminal in Abu Dhabi. There was a big initiative on recycling and sustainability for that project, but also the company built pipelines, oil and gas refineries. And
wait, the 3D printed buildings though?
The 3D printing building was in Saudi Arabia
Saudi Arabia. So I haven't visited that one.
No.
And they only printed that one building?
It was only one building. It was supposed to be a 3-phase project, but we, due to financial problems at the time.
Did they purchase the printer?
No, it was leased.
But they own the rest of their equipment, they own themselves, like the dozers and stuff you're saying?
Yeah, the general contractor, we were the general contractor, so we hired CBay at the time as the subcontractor. So
nice.
It was back-to-back contract, and then we just handled them just as any other subcontractor.
So is that more typical in Saudi Arabia? In America, there are some GCs that have their own large equipment, but most companies would lease or do a rental.
And as the years progressed, we were moving towards leasing only because it was hard to find the spare parts. But we were also looking at, for example, 3D printing spare parts for the depleting or the aging fleet that we had. So at that point, it all depends. But again, the construction market sort of like went through sort of waves of up and downs. So I think since then the company has gotten rid of their fleet, but are now leasing just because of the overhead that it caused.
Yeah, cool. So where are you located now?
I'm in Toronto area in Canada.
Cool. Is there prints going on there that you're keeping?
Oh yeah, I've got a cobot printer, I think in 3-hour radius from me. So I have in Windsor, which is the Habitat for Humanity project. I have Nidus 3D, which is in Kingston, Ontario. And then Rochester, New York is where GE has their cobot research printing.
Yeah, there's also a Telecom printer on the states side, not so far away near the Great Lakes,
Yep.
in Detroit. Yeah, I'm in Houston now, which has a lot of printing companies around here, but I'm only here maybe 40% of the time. Last week I was in Colorado visiting Ron Real and Emerging Objects. They're doing an Adobe print. It'll be the largest Adobe printed structure in the world when they complete it.
Very nice.
But it's not one, they moved the printer a few times. So I think the Tekla House, they moved the printer as well. But Adobe seems pretty promising and their systems were going really well. It doesn't harden like concrete does. So it's not as much of a mad rush to get everything clean at the end.
Yeah, exactly. And there's been many companies around that have been doing the geopolymers as well. So Renka is one of them. I know we had talked initially when we contacted Renka, it was about 2016 in Dubai for a project, but there's a lot of promising possibilities when it comes to geopolymers and
yeah, I actually did a podcast with Renka that'll come out probably before this one. Pretty interesting. It's just unclear where geopolymers will fit in. There's not a lot of supply of geopolymer in terms of the silica-based geopolymers, which is usually what people are talking about. I mean, concrete's a geopolymer to begin with, so there's a lot of myths around geopolymers, but I don't know exactly how we could put it into one clean geopolymer myth.
Well, if you can certify the structure based on existing standards and thresholds, I'm sure that whatever material that you're using will just pass the bar. It's not necessarily which material I use. It's just as long as you get performance requirements that you require from the structure that you're printing. So I don't think people are too picky. Well, they are, but I mean, it's based on your CO2 footprint, your sustainability, what your initiatives are. To get that, but it doesn't necessarily mean that you have to be stuck with the cement and concrete.
That comes back to another great point about Adobe. There's already great standards for Adobe structures, so you can kind of sweep the 3D printed fact under the rug and say, here's our Adobe building, and that should be much easier from a permitting perspective. I know the project they did in Colorado was fully permitted. They had footings. It'll have electrical, plumbing.
Yeah. And also, we're trying to address that we're trying to address the geopolymer and Adobe materials and clay in the ISO standard that we're developing, and hopefully we get it published by the end of the year. So we have cement, concrete, clay, Adobe, and geopolymer referenced in there. Also, synthetic stone and other materials like Mighty Buildings is using.
And so, when somebody wants to get permits, how will those standards help them in a new region?
Yeah, for one thing, it's now the issue. I think the biggest issue now is that when you have an engineer or technician going to your site and looking at the drawings, they're looking for, okay, where are my traditional support structures and how is this building standing up and how do I certify it? What we're trying to do with this standard is actually say, okay, here's your 3D printed structure and here are your existing ASTM and other standards that you are used to certify your structure, and this is how you certify it. So you have this, if you're doing load bearing or you're doing tensile strength or you're doing seismic requirements, here's your existing standard that you use on a day-to-day basis, and this is how you certify it using that. So we're trying to, at this point, we're just trying to make people understand what 3D printing is and that you can actually relate to it. Sort of like taking the horse in the carriage and get rid of the horse, but just leaving the carriage there so that, okay, it's a step at a time type transition to get to 3D printing or the Tesla car. We're not saying, okay, remove the horse and carriage and here's a Tesla car, but it works the same way. That's too much for people to understand. So step by step, we're going to make that transition.
Yeah, certainly. And there's some existing standards, for example, AC 509. I can think of a bunch, but can you just describe some of the shortcomings in AC 509?
From my experience and my understanding is that every time you have to go AC 509, it's a very, very expensive process because you have to certify the material. And if you change the material composition that you're using, you still have to go through the same testing and same process. Not every startup and not every company can afford to spend that money. There are companies out there that can, and kudos to them for making it. And also because it is in demand in the market. So you have the Black Buffaloes, you have the Contour Crafting, and you have the other companies out there who are actually certified AC 509 or getting certified AC 509. And that gives them under the ICC, which are widely used in the United States codes. But when you go international, other companies are not as capable as these startups to actually get that certification. So the global standards that are out there are, again, our day-to-day process that every general contractor or every engineer or technician has access to, because that's part of their business, and that's how we're certifying the structure based on that.
Yeah, I mean, from what I've seen in AC 509, there are some pretty damning details, like you can't have a 2-story printed house.
And that's what the modification that Black Buffalo is doing. So they're actually going to the 2-story building. So to get AC 509 certified for 2-story buildings and more, but also trying to certify the materials that they're using. And since Black Buffalo, for example, is moving to hempcrete, they'll probably introduce that as part of AC 509. I cannot speak for the company, but just assumptions. But they'll have to go extensive testing on that to get AC 509 certified.
Yeah. AC 509 also says you can't rely on any structural integrity from the printed concrete itself.
Okay, so which means that you still have to do your rebars,
vertical columns.
Yeah.
Will you be able to avoid that rule?
Not necessarily, no.
Oh, that's too bad. I'd say that's the real big step that's required to realize some of the cost effectiveness, if it's even possible.
Yeah, but that goes back to the horse and carriage and just changing the horse and carriage and bringing in the Tesla. You have to take it one step at a time just to get people just to grasp the concept of 3D printing. There might be studies out there, there might be transitions out there where you can eliminate the columns and the beams based on how you print your walls. So if you have a 3-layer wall and you have, like, let's say, a honeycomb type of pattern within your middle and your inner layer, that will probably be your structural element and your load bearing element for the structure. The outer layer will be will eliminate your bridging so that you have the insulation requirements for inside the house. So there are many ways you can actually do that based on how you print. If you need to do 4 layers, for example, and do a certain pattern to get the structural strength and the seismic strength, that all depends on your architectural design and how you want to do that. So there are ways you can eliminate the columns and the beams, but again, it's one step at a time and not just jumping from A to Z from one shot. So we have to take it in transition. So for now, I still see that people will be printing with rebar and conventional concrete columns and beams, but little by little, we're moving away. And that's what we're doing with ASTM work items, is that we're shifting from your traditional approach and going to the more 3D printed and innovative approach of actually building your structures without having to resort to columns and beams and rebar.
So does it make it more difficult for companies to attempt structures without vertical columns and rebar?
You have to understand the general contractor's perspective on this. The general contractor takes ownership and responsibility for the building that they build. So
that's the engineer, not the general contractor, the architect, the engineer.
The general contractor also has an engineering team sometimes that actually takes on the responsibility for that. So at the end of the day, if the building collapses, the general contractor is liable, or for us as a general contractor, which we had our own certifying engineering team, had to issue certify the engineering drawings that come out there. We had a third-party consultant who would come in and say, okay, yes, this is approved, so that we don't sort of cut corners. But the engineering and design, everything had to be done within house. As a general contractor, you have the responsibility of taking on that liability and that risk. And in order to get that done and to continue doing business, you want to ensure that the building stands for the duration that you're guaranteeing the building for. So you don't want the building to collapse after 5 years or 10 years just because we made a mistake somewhere. So there's a lot of sort of responsibility. There's a lot of risk that comes into play. So in order to avoid that, they will do the overkill and do the beams and columns just to ensure that extra check that of safety and warranty that the structure is actually going to stand.
Yeah, which is why it seems unfortunate you can't come up with some method of testing which could relieve the necessity of vertical columns and rebar.
That's happening, and this is why we're pushing it from the ASTM side to actually have that. We have a work item that's specifically dedicated to 3D printed element design, evaluation, and testing. So that's going to be doing that work to actually put the standards together to actually certify 3D printed structured elements without having to resort to traditional means and measures to build.
Mm-hmm. Great. And when it's published, is there a review period, or will that instantly be applicable for construction?
No, all the standards that get published go through a two-process review. So it goes out to the public, committees have to comment on it, approve it. If there's negative comments that come in, they have to be addressed. Negative means that the standard stops in its tracks, and you have to resolve those negative comments that come in for your standard. So those are critical comments that come in as negative. Some people might comment, but they may not be a showstopper. But the negative comments, if they come in and when they come in, are showstoppers, and they have to be addressed because there's a critical concern coming in from the general public or the committee members that says, okay, well, you have to address this.
Is it funded by the committee members?
No, everybody who's actually putting their effort into this is volunteered time.
There's no cost.
It's your own cost. Everybody assumes the cost on putting these standards together. So when I started Joint Group 80, that was on my own. Nobody's paying me to do this.
But there's no fees with ASTM or anything. So you guys didn't need to raise any money, just your time.
Just time.
Good. Very nice. Is there any other myths that are sticking out that we skipped?
One big one is that construction 3D printing is just concrete and it's just houses, and it's not. Additive construction is metals, polymers, plastics, recycled materials, and everything. And it's not just houses and walls. It's metals, it's bridges, it's spare parts, it's digital inventory, it's anything and everything that happens in construction to do that. So additive construction, just like you see now in the military, where they're actually installing these 3D printing elements and little mini factories on the battleships and aircraft carriers to actually supplement this digital inventory type thing. This is the same thing as in construction, so it's not much different. So you have remote areas in construction where like people or the big general companies have to have this big huge warehouse where they have the spare parts that they might or might not use, and it's just an overhead in terms of cost, in terms of logistics, in terms of manpower. And this could be actually circumvented by just 3D printing elements that you need, or the components that you need at the time when you need them. Also eliminates the issue of lead time, especially if you have to wait for 3 or 4 or 5 weeks just for a spare part to come in.
Yeah, definitely. If somebody has like whatever they need their material printed in, whether it's a metal printer, maybe it's even a plastic part. Pretty much every 3D printed construction site has something 3D printed that they're like, look, we needed this, so we just used our little printer over here to help the big printer.
Exactly. And even sometimes, I mean, we used to machine things together just as a temporary solution until the real part came in, or the part from the OEM came in. But again, you can actually circumvent that by just providing a better performance and a more accurate part by just 3D printing it.
Cool. So that covers quite a bit. I'm trying to think if there's any other big myths standing out. How long is there a period that you have to wait after a house is printed before somebody can move in?
It all depends on the certification. And now the engineer and the architect have to come in and actually certify the structure. So it all depends on just your typical construction. So as soon as the finishing is placed, I mean, you cannot put the tiles and you cannot put the grout, or you cannot put the sheetrock unless certain requirements apply. So the same thing happens for 3D printed. I mean,
I think there's something else too, preventing people from moving in on time. I've just seen it's been a little fishy. Some of these houses are not occupied yet, or the tenants have been told they're not supposed to move in yet. Maybe it has to do with the fly ash or something.
I'm not really sure. I think from my perspective, the only thing that would delay move in is the certificate of residency. If you don't have that certificate of residency, then nobody can live in the house.
Mm-hmm.
You can use it as a model house where you can showcase the house and for people to just come in, but nobody to reside in it. So the certificate of residency is a critical part for people.
Are there any homes in North America that you're 100% sure somebody is living in full time?
There's the two houses that Alquist printed in Virginia.
I'm not sure they've moved in yet.
I've seen something that they did. So
They did a ribbon cutting day.
I don't know. Based on again, social media that I see, there's two houses in Virginia that are actually certified for occupancy.
Yeah, I'm not positive that those have been moved into. I don't know. I know the one in Arizona, the Habitat project there, I don't think has been moved into yet. And the other projects are all Airbnbs or like overnight stays, or nonprofit projects that were given away. It's interesting. Once they give the house to somebody who lives there, I don't go there anymore. I don't want to, like, it's a private residence. When it's a construction site, I feel differently about it. And I don't mind being in like a public street filming something that I'm whatever publicly allowed to. So I need to, I guess, wait and see after they did the handover. Sometimes the people who move into the house contact me because they were excited about 3D printed houses. Maybe they saw the YouTube channel. They're like, oh, maybe you want to do a video or something with us. So if they ask me to, I'm happy to do a video with them and hear their perspective about what they think. I'm sure they'll have valuable feedback, improvements.
Oh, absolutely. I mean, especially when you're not used to concrete or cement-based materials as part of your construction. I mean, many people here, especially in North America, are used to stick-built. But the concrete structures are very typical in Europe and Middle East and other regions in other countries. So it's not much of a transition to be in a 3D printed house. It's just a different way of actually constructing your houses.
Do you think those 100 home projects will actually start this year?
I hope so. I hope so. I don't see any issues. Why not? The only thing that I can see again is the certification and getting the permits and everything like that in place.
The major issue I see why not is the mortgage rates in America are going through the roof. They're double what they were this time last year. So there's the home builder sentiment has really deteriorated in the past couple months.
Yeah, it has. But again, it's not something that will be permanent. But also, I'm not sure if there are any other initiatives or organizations that will be funding these projects, and especially if it's for affordable housing or for a certain segment of the population, so that the funding will not be an issue, and it will be subsidized housing in some way.
Interesting perspective. In Canada, there's a lot of money for subsidized housing.
No, I'm not really sure, actually. So, but based on what I know is that with initiatives like Habitat for Humanity, there are ways where you could just sort of afford a payment. Yes, you have to still, I mean, but the misconception with Habitat for Humanity is that you just get a house for free, which is not. You still pay your monthly bills, but it's sort of reduced in a way that you can afford to pay your monthly payments and not have to worry about like fluctuations in markets and stuff like that. But there is still a monthly payment when it comes to Habitat for Humanity.
Yeah, it'll be definitely the interesting. It's hard for me to imagine there'll be 100 home projects completed by the end of the year because it's only 6 months away.
I mean, like if you look at 2020, there were hardly any projects in the US when it comes to 3D printing. We are in the middle of 2022, and there are more projects than you can ever imagine in the US alone, and they're coming up really quick. So I would say, just hold on.
Yeah, I mean, I remember the first 3D printed house in America. I put on my YouTube channel. I think it was the first video of it on the internet. I found it in like a concrete plant. I was just driving around Long Island, checked. It was like the third concrete plant I checked that day. But yeah, like you said, now there's so many of them. It's progressing really quickly. I don't mean to sound disappointed with the speed. It's just there have been at least 3 groups saying 100 home projects this year. So
well, with construction, well, yeah. But again, if you're coming from the construction background and we have timelines and deadlines, some of them happen and don't happen.
None of them happen.
with typical construction, even somebody says, okay, it's going to take 2 years. It takes usually 5.
Yeah.
And usually when they say they start a certain date, it starts 5 months later or 6 months later, or if not a year later. So it's going to happen. It's just, you just,
a lot of people were hoping 3D printed construction would be the end of that.
what we maybe later on, but we'll see how it goes. Again, 3D printing is just a tool in your construction project. It's not going to be your all save, fix everything type solution. So, and
yeah,
it
from my
has to
perspective,
address.
it's really about the future. Like people are investing in learning how these systems work, learning how to implement robotics on the job site safely, with people increasing the number of people trained, especially all the universities teaching students, increasing the job pool. So it's not, even though we're saying some negative things about the myths, people overpromise, a lot of marketing people especially, but the realities are good too. It's like headed in a positive direction.
It is, and the market is so big in the construction sector when it comes to 3D printing. There's going to be enough playing field for everybody to participate in it. So, but the more you use it, the more people get aware of the technology, the more research happens, the more research and development improves the material and the technology, the cheaper it gets. So the more players, the cheaper the solutions, the cheaper the materials, and people get used to it. And then just like anything else.
Yeah, it'll be nice to see really large batch plants producing concrete at scale.
Yeah, we'll get there.
Have you talked to many big concrete suppliers?
Well, the concrete suppliers that are now are pretty known. So for when it comes to 3D printing, that they're the big concrete suppliers that have actually provided the material, either in batch or in sacks or in bags. But again, it's a learning curve. So people are developing that kind of material, but they're not maybe developing it at scale. But also they have to learn that, okay, even though it works in one location, it's not necessarily going to work in another location. So even though a formula works in Europe, doesn't mean that when you bring it to Canada, it's going to be the same magic sauce.
In America, people have to disclose all of the ingredients of a bag of concrete when you sell it to somebody.
Mm-hmm.
Is that problematic is that preventing people from wanting to invest in experimenting or
No, I think as material suppliers, I think from their perspective, there's a lot of possibilities and promise in the 3D printing industry, where everybody's actually looking at that. There's a housing shortage that needs to be met. It's not going to happen through traditional means and building approaches. So everybody's actually looking into that seriously, to actually develop material for 3D printing and to actually enter the market. So not just the big 3 or 4 that we know, there are other companies that are actually investing into this.
Yeah, I'd say the materials is the one thing that could be an overnight change for the industry if the material cost was definitely on parity with traditional concrete. Mm-hmm. It's really exciting possibility. It's just hard to get a sense of if and when that'll happen.
Again, there's a lot of research going on. I just finished a call earlier this morning where a company was actually, it's not one of those major popular material suppliers, but they are looking into it, and they've invested the past 4 years researching it and moving forward with it. So it's happening. So the more people are involved, the more research, the more people use, the more feedback you get from the market, the easier it helps. So that's why you're going to see the benefits as things happen. And people start doing things at scale. So when it comes to the 100 houses and 200 houses that are going to be promised to be printed, I really look forward to that, because this is going to open the doors as to what's working, what's not working, how we can improve the technology, the material, and what else can we do with 3D printing.
You say what's working, what's not working. What's working?
Well, everything is working to some extent, so you can't say that something is not working. Again, to benefit, to see the realization of the cost benefit and everything, you have to go on scale. You cannot just put everything on one project and expect, okay, it's more expensive. Well, yes, it is going to be more expensive because everything is sitting on that. Maybe there's a new way of delivering your material. Maybe there's a new mixture compound. Maybe there is something that works in Texas and something that can use in Ontario without having to change too much in terms of material composition and formula. So it's a learning process that we need to go through. But again, you only learn that when you do mass production and mass scale type implementation.
Yeah, it's hard for me to say any part is working because every single part is a work in progress from my perspective and needs improvement. So it's
but everybody's trying something different. So you have those that are going mortar, you have those that are going regular concrete, you have those that are going adobe, you have those going in clay. So you have multiple initiatives going in one direction, different directions. And we don't have a consistent to say approach to how we're going to move forward. But again, it is a learning experience. We're getting there. There are projects, there are real things that you can touch and houses that you can feel, and they're there. You can visit them. But again, little by little, we'll get there to this mass.
Yeah, I think I've visited more than anyone in the world.
Yeah, definitely. And in different locations. I mean, like from the extreme heat to the extreme cold to anything and everything in between.
That's why I know that there's nobody has it like set. Every single aspect of every single project needs improvement. And so what it needs is lots of people motivated, willing to do the improvements and do the stuff that doesn't work best, because that's how you take the baby steps, like you were saying, from the horse buggy to the Tesla. And it's hard. It's very hard. The people on these job sites, they're putting in long hours, they're sweating, they're using their minds tremendously, and putting in tremendous effort.
And that's why having committees like Joint Group 80 and ISO ASTM, and also the ASTM committees that are working towards these standards, brings all these people together. So you're not sitting in a silo, just on an island somewhere trying to figure out your problems. In addition to actually putting standards together, it brings the community together to actually discuss issues and find problems. So that's a source of discussion and a knowledge sharing opportunity when people get involved in these committees.
Yeah, I know people are very hesitant to share their private information with groups like that, though, because they don't want to just give it away. I know a lot of tons of information themselves.
We're not asking for proprietary information, and we're not asking for either on your material side or your technology side. It's just the common issues that you think that will move your business, can be resolved to move your business forward. So let's say if you want to do a structural element and you want to do your testing, what do we need to do to make that happen? And what do we need to do to make your business successful or move forward and remove the stumbling blocks that you're running into on a day-to-day basis? That
sounds like you're going a little above and beyond what a typical group to establish ASTM standards might. Like there needs to be some kind of shared database, right, for these companies, especially when it comes to the material regionally. If you can get, I guess that's proprietary to them.
We're not looking at specific proprietary information from the material suppliers or the technology providers. We are not
but that would be a huge benefit. For example, if they shared their material data, that's where people would be, it would really help. But it's, since they know their region, they want to own their region. So they don't want to give away the secrets to printing in their region.
Well, again, it's not something that
So what's an example of something non-proprietary that's helpful for them?
Testing load-bearing walls. Is there a specific print pattern that we can print so that we can avoid rebar and concrete?
Perfect.
That's something very basic, irrespective of material and technology that you're using. So these are the things that we're trying to make sure that get put into standards. Taking your 3D model and actually getting to your 3D printed element, making sure that the details in your 3D model are actually transitioned to your 3D printed element and nothing is missed in the translation or the conversion that you're doing. You're
getting dangerously close to slicing, which is proprietary.
Yeah, but I mean, like, just to ensure certain guidelines that you have to follow to ensure that the quality of the model is actually translated to your 3D printed element.
Yeah, I'm sure it's a little tricky to balance having them help each other and competing with each other at the same time.
Well, I mean, like, again, people participate, some people stay silent, some people participate, some people once in a blue moon say something, but it's constructive and it helps. So, but it still brings that okay, there's a place you can go to actually, if you're stuck and you need to ask somebody, or you can come to me and ask me, and then I can try to get that information to you in without trying to impede proprietary information or things like that. But there's the whole concept of bringing everybody together is that there's this group, this openness that we're there. We're not asking you to, there are no restrictions into saying, okay, well, you have to provide 1, 2, 3, 4, or you don't have to sign an NDA or anything like that to be part of this. It's an open discussion, and it's up to you how much or how little you want to share in these discussions, but it's there.
So after it goes it's published and let's say it gets reviewed, approved, I'm sure that'll require some level of attention. After that, though, what's next for you?
More standards and more consulting. So basically what I do now is I am very passionate about 3D printing and construction. So for me, I will do anything and everything I need to do just to push this industry forward, because there's a lot of potential in it, even with all the hesitations that are there, and even with all the stumbling blocks that are there. I see the potential in it, and that's why I'm investing personal time as much as I am professional time in this sector. So, but also helping doing the things that will enable this to happen. So standards is a big thing. As coming from a general contractor perspective, nothing happens in construction without standards. So the standards have to be there for everybody to actually recognize and say, okay, this is a viable product that I can actually build with. So this is what I'm going to use in order to actually certify my structures and move forward with it. So that gives you peace of mind and your guidance on how to actually print. So standards is a big thing. And again, as soon as we publish a standard end of this year, hopefully, we will start working on the revision, and we will continue to expand on it on the work items that we have with ASTM. We're looking at sustainability, we're looking at safety, we're looking at circular economy, we're looking at design optimization, we're looking at structural element perfection. So there's so much that needs to be done, and shift away from the rebar and the concrete into more eco-friendly and more efficient way of actually building.
Once you have the standard in the system, is it easier or quicker to make revisions to it rather than establishing it from the get-go?
Yeah, it is easier because you're amending certain tasks and certain clauses, but the main document stays the same. So it's just like adding an addendum or a revision to an existing document. So
yeah, it seems like time prohibitive. It's been like 3 years trying to get this one going, and when you finish that for the next one to be another 3 years, that's too long.
So no, not necessarily. The typical takes 3 to 5 years. We officially became a committee in March of 2021. We hope to issue, we finished the second draft. So it's the final draft that goes up in May. So it took less than a year, or a year and 2 months. And we hope to publish by the end of the year. So it's a year and a half at most from inception to publication.
We talked about Joint Group 80 on our last call 2 years ago.
We didn't start it yet. I was just gathering the people.
You were putting effort into it.
Yeah, well, now everybody's there. So
your time is valuable. It counts. It counts. The efforts from the beginning to the end.
Yeah, it's well, yeah, but still it's shorter than your typical time frame.
Yeah, I would just hope that we could have it as fast as possible, so that if a company comes out with a great innovation overnight, there could be a regulation equally quick to make it work.
And it all depends on your participating committee members. So if the participating committee members see an urgency to get this done, and as they have with Joint Group 80 and with the ASTM committee members, we will be able to get something published. If it all depends on the momentum that you have within your committees. So the 3-year timeline is not just a rule. It again depends on the momentum of your committee members.
The last myth I want to talk about is that you have to follow international construction standards for construction projects in America. There
are certain standards that you have to follow. Everybody uses ASTM standards in the US. So if you look at the certain standards that are being referenced as your building codes, you're still referring to certain specific ASTM standards within those building codes.
There's lots of references and it's used frequently, extremely helpful, beneficial for everybody, but there's no requirement for any international code or ASTM on an American construction site. It's just a supplemental additive thing for engineers to look at, like you mentioned.
For us as a general,
not a legal requirement.
Yeah, for us as a general contractor, we were dependent on standards to actually move forward with any project. Without standards, we didn't move forward, and not necessarily specific ISO or specific ASTM. Some people told us that they need to use the British building codes to build the project, so that's what we use. And so everybody gave a stand, but there have to be standards implemented. Whether they use ISO, or ASTM specific standards within the US construction company, we are looking at it from a global perspective. So, and the best way to actually get a global perspective is through ISO and ASTM, and that's why we moved with this initiative that way.
Definitely. And it'll be like right now, there's nothing to go off of besides AC 509. So just having anything is going to be tremendous. Even though it's not a guarantee, it's a guide. Instead of walking around blind, they're walking around with a little string on the wall.
Yes. So again, it's a start just to get people used to it and familiar with it, to actually how to accept it and comprehend and move forward with it. And then the next step will be, okay, little by little, moving away from traditional into the more innovative and sort of enabling this architectural freedom that you can get with 3D printing.
Definitely. Do you think you'll stay in Toronto?
For now, yes.
Cool. There's a huge housing need there. So as more of these companies pop up, I think it'll be a good city for 3D printed construction.
Yeah, there's a housing shortage all over. I mean, this is the reality of things. Again, there's many statistics out there as to the housing requirements and the deficiencies that we have existing market. But there is plenty of work for everybody to tap into. So competition is not necessarily that somebody has to dominate the market. It's just who can catch up to meet the demand.
Are you a fan of Drake?
A little bit, yeah.
He lives there, right?
Yep.
Toronto and the Nelk Boys.
Justin Bieber's here. We have everybody here.
Yeah, cool. Is there anything else we left out that people kind of that are just looking at the surface level of 3D printed construction they might not see?
I don't think there's anything else that comes to mind now. But I mean, again, if you're starting off 3D printing construction and you're lost, don't be. There are many people out there that are willing to talk and discuss things, maybe not openly and on a Zoom call but maybe on a one-to-one basis. There are people that are willing to discuss things and help out. And it's not that everybody has to work on a silo, especially when it comes to standards and it comes to things like that. But it's a very small and close community, so you don't have to do this on your own.
Yeah, those are very true words. Especially, I really appreciate you coming on to have this hard conversation. It's one that not a lot of people would have. There's a lot of these companies, they're trying to raise money and stuff, so they never want to say anything remotely negative. So I really appreciate that you're willing to have like these honest conversations and bring the parts that are usually left in the shadows to the light. So yeah, if people want to contact you, how do they get in touch with you?
Best place is LinkedIn. So Stephan Mansour, Stephan Mansour. Just reach out and be more than happy to discuss and have a call and a chat. And if you need help, we're happy to help you either with the standards side or with trying to get into construction sector, or if you're a GC who wants to get into 3D printing, again, just reach out. That's the easiest way to do it.
Awesome. I'll make sure to, if not before then, schedule a call with you after it's published, and then we can talk about that. That should be an awesome.
Yeah, absolutely. Definitely.
Awesome next step.
Great.
Cool, man. Thank you again. Really appreciate it. And just to catch up with you.
No worries. Always nice to talk to you, and best of luck in all your future endeavors.
You too. All right. Later on.